So for some of you, I spoke yesterday about some of the important product supply and operational intelligence initiatives that we have. So I'm going to revisit the overall premise of what we're working on, but then really tie it to an emerging relationship they're having with OPC Foundation and some of the critical initiatives that really can make this possible. So it's always important to start with, what are we talking about before we get into the foundational reference architectures and communication. So what I spoke to yesterday was Procter & Gamble's committed to introducing AI and machine learning models to the thousands across our operations with a particular focus at the equipment level, and then having the equipment collaborate across key work systems, whether it be quality assurance, maintenance, HS&E, material utilization, et cetera, et cetera. So what I'm going to describe is how we not only invest in the cloud and on-premise installations, but also what we're doing at the control edge, not just the OT edge. So before we get into what that looks like in the value and the architectures, we got to start with what are we solving, right? So I spoke to yesterday, and I'll do it briefly. There's four fundamental things that we see in our manufacturing sites that need to be addressed. Number one, and this is really paramount to our relationship with OPC and OPC UA, is we need to get the data out. We need to get it at the right time series, and it's got to be contextualized. So anywhere in the architecture, we need to be able to access that repeatably and be able to scale that over and over again against different operations. Once we've done that, this is where the subject matter experts and the data scientists have to figure out how to work together. It's not so easy. Once you have the data, you have to be able to explore the data, perform the different data science exploration techniques, and come up with an algorithm that you can depend a 24/7 operation on. But then once you have that algorithm, usually this is done between engineering and data science and manufacturing, this algorithm has to be put into a 24/7 operation. So how would you operationalize a model and have it run, in this case, on the control edge, with the resources that work in manufacturing, not just IT. And then finally, once it's running, I have to run it for the next 10 years. And so what we all should recognize with this data, with the data model, with the model that's running, it's going to drift, it's going to adjust. So what is the DevOps and MLOps environment that will support the integrity of machine learning times the thousands across 120 sites against 10 to 20 different workflows with the same confidence that we run traditional controls and automation? So we introduced a few things to try to simplify this. I've been in my job, and I didn't describe my job, but I'm the vice president of smart platforms in corporate engineering in P&G. And I've been in the job 5 years, right? So we talked about how long does it take to do a digital transformation? Well, it takes some time, and it takes some failures, and it takes some learning. But in this case, about 2 years ago, a nice healthy discussion between my leadership and I was, this has to get simpler. This has to get more repeatable. We have to create a menu of products and services they can buy and apply with confidence. My first answer was, it's not that simple. I don't think it can be that simple. Well, the reality is, over the last few years, we've been committed to making it that simple and finding industry partners, government, academic, foundation partners to help us make that simple. So this slide describes where we're at. We've created a technology stack with the industrial automation partners to be able to deliver GPUs, IPCs in a very consistent manner to perform DevOps on it in the control edge. And then we've introduced WISE as a end-to-end lifecycle of both support of those assets, but the machine learning lifecycle more specifically against the use cases that we need. But underlying that is what I'll get into, is there needs to be this network communications model that go from sensors to controllers to the OT to the cloud, and then all of the different bi-directional nature of all that information. And we've, as I get to the punchline, we see no better way than to perform this through OPC Foundation's introduction of OPC UA in its broad different forms. So what we're trying to achieve with this is, machine learning AI is a nice buzzword. It's been achieved by really brilliant people in pilots, in demonstrations, with very great partners across the industry, but it's been very difficult to scale. There was a percentage given by Gartner just a few years ago that only 10 to 20% of industrial IoT or machine learning solutions scale across the company. It's a pretty scary number, and we're trying to crack that by getting this done in about a tenth the time, 10% of the cost that we were achieving, and with much higher confidence. So that's the objective of what we're doing. And as I get to the OPC connection, it has to still be fundamentally sound on the communication and data. So I'll give you a general kind of nice conceptual drawing of what we're trying to achieve. So you can imagine that Procter & Gamble, we have wide variety of OEM equipment across all of our different business units. Some well-managed, some managed through the OEM, some written by Procter & Gamble controls engineers. Well, regardless of the maturity of those production assets, they're gonna have to be connected and be able to harvest the right data model to serve our machine learning objectives. So we've chosen, as I said, to introduce a control edge device that can talk to any number of our control vendor platforms, do it in a very consistent way, and do it through standard communication protocols like OPC UA. Once that information is in the on-premise VMs and servers, it also starts to permeate up into the cloud and also from VM to VM. So we see this need to have this information flowing across these different parts of the Purdue model. And what we recognize is that a whole machine learning lifecycle that will support that from the equipment all the way up into the on-premise, into the cloud, and then back down all the way to the control edge. Because our premises, many of the algorithms that run machine learning in our core work processes don't and will not run in the cloud. They will actually run down next to the control system, particularly for our things that are gonna really run adaptive control. But we have the ability to run these machine learning algorithms in the cloud, on the prem, or on our control edge device. But inevitably, it still has to be a nice flow of information in a consistent manner. We've also introduced this concept of WISE, which is a codified approach to machine learning that allows for everyone in Procter & Gamble, particularly in manufacturing, to understand where you are in this phase. And it's really not a linear process. This should be a cycle, but it's hard to write this as a cycle. But you see that on the bottom, the different hardware assets and infrastructure and where it plays in the cycle, how OPC UA is the avenue which the information flows, and then the different stages, I would call them, in that cycle of machine learning, all the way to maintaining the model in operations indefinitely. So for us, WISE is not only a conceptual model, it's a model of services that we're going to introduce through Procter & Gamble and our partners, and it's going to make sure that everyone performs with integrity machine learning for manufacturing. So we bring it home here. There's a lot to be done in those conceptual slides, right? Those are nice and pretty and fancy and exciting, but in the end, we got to build all the layers of the cake, right? The machine learning algorithm, the UX that runs on top of that. To me, I always call it the frosting. Well, we got to get into making the cake, and we got to get the right ingredients. And we find that some of the initiatives that are going on with OPC are vital to us with the right ingredients and the right cake. So, you know, John Dyck's in the audience here. Him and I have had a nice, healthy conversation about the Purdue model has been really good to serve us well for many, many decades to play our position on the field, whether you're a sensor vendor or a control vendor or a server or level 2 provider. Well, in the end, we've been respecting that for too long. What we really need to do is start to blur some of the levels of the Purdue model so this can be a much more broadly communicative architecture, much more open for everyone to participate. Now, we'll still have to do the best job as a sensor provider. You have to do the best job as a automation provider. You have to do the best job as a level 2 hyperscaler and others. But in the end, if we don't introduce this more agnostic network of things rather than what we see in the Purdue model, I don't think we can deliver Industry 4.0 or the power of intelligence. Additionally, we're all introducing cloud, right? There's our own internal clouds, there's the open cloud, there's our proprietary clouds, there's the field device to cloud. I think we also need to pay attention to what this is going to look like, particularly for supply networks, right? I mean, I can talk all day about a manufacturing node, but those manufacturing nodes are now going to be complemented by very important distribution nodes, customization nodes for Procter & Gamble. So as we build this intelligent architecture, multiple nodes, multiple sites, multiple clouds, and that being able to flow where it needs to flow for the algorithms is going to be vital. Again, these initiatives from field to cloud or cloud to cloud are going to be very important, and OPC is at the forefront of defining what that should be. And then finally, I'm a controls guy, so I'm in love with the field, right? I love sensors, I love vision systems, I love advanced sensors, and they have to be able to effectively flow, right? To the controller, not to the controller, and the world that we're building is certainly around that. So I'll give you an example for us. I was just talking about our sustainability efforts, and one of the exciting new projects for energy and water analytics is to harvest energy and water sensor information through LoRaWAN. And the LoRaWAN is going to be communicating to a smart box, and then it's going to be provided to the cloud. So those are some initial examples where we're not going to respect the Purdue model. Why should we? We're not going to take the complexity of sending information through different layers when it really needs to go to where it's going to play, and do so with the highest integrity, cybersecurity, and common standards. And we want to roll that out to all 120 factories, hopefully within a year. You think we're going to do that if everybody's doing that a different way without the common protocols? No. So this just gets us not only very, very proven approaches, but gets us speed to implementation and a common language. And so we're all seeking to have a common language, right, between IT and OT. Well, I see no better way than what OPC Foundation is offering Procter & Gamble and all of us with these initiatives. So if I close, because I want to make sure we have time for everybody else. As I said, I'm a controls engineer who is tolerating the term OT, okay? Because I think OT is very generic for what we accomplish in controls. And we're committed in Procter & Gamble to make sure that the controls assets are respected and they're part of an intelligence movement. I also bring up this slide, and sometimes I write the independence movement, because the control system will perform intelligence with or without on-prem and cloud installations. But I'm committed to making sure that we can do both. So in our less mature sites, the control edge is going to be served, and we're going to do intelligence whether we have all the rest of the infrastructure or not. And when we have the chance to be thoughtful and mature with OPC and other solutions, we'll fulfill the whole reference architecture.
Ladies and gentlemen, I just wanted, before we let Jeff escape, I'd like to share with you a thought or two on how Jeff and I met. We met in San Diego last year at the Industry of Things World USA. And it was remarkable. I was there with you and Kathy St. Clair, another rock star controls engineer at Procter & Gamble. And we started to talk about the synergies between what the OPC Foundation does and some of the work that Jeff and Kathy and all of his teams are doing at Procter & Gamble. Immediately, we started to say, this is good, this is helpful. So one of the things I'd like to announce is that Procter & Gamble is our 900th member. We're very grateful to welcome them into our organization. Before we dismiss Jeff from the stage, I'd like to shake his hand. We're going to have Peter give us a little time for a photograph here. And if we could, we'd invite Stefan to come up on stage and just be with us. We'll do the three-man handshake here.
What am I signing up for you?
Well, it's not a blood oath or anything.
Thank you so much for your commitment, Jeff.
You're welcome.
Should we go more to the front here?
Yeah, we could do that.
But don't fall.
Yeah. Thank you, everyone. Now that Stefan's on stage, we'll turn some time over to him for the update.